and finally we'll talk about it after Dr. Ahmed finishing, Dr. Fahd finishing. Okay, let's start. Sharon, can you stop sharing your screen? Okay, Dr. Fahd, time is yours. You can share your screen.
I am trying. Can you see my screen?
Yes, we can. Yes, we can start.
Do you prefer to start now?
Yes.
Okay. Hello, everyone. Good morning, or good afternoon, or good evening, whatever where you are now. It's me, Fahd Al-Ahmadi, from Saudi Arabia, Ministry of Environment, Water, and Agriculture. My presentation is about machine learning and deep learning in GIS. The content of this presentation will be, is machine learning one of the emerging trend in GIS? What's machine learning? What do we mean by machine learning? Machine learning general overview, the big picture of machine learning, then machine learning methods or categories, and then machine learning algorithms. Can we say spatial machine learning or spatial deep learning, spatially explicit machine learning algorithms, machine learning in GIS software, machine learning using programming languages, top machine learning libraries in Python and R. The first point is machine learning one of the emerging trend in GIS? Esri Canada published an article in their website about the 7 GIS trends, a call to action for planners. And one of these 7 trends is geographical artificial intelligence, GeoAI, machine learning, and deep learning. Also, Esri in ArcGIS Pro, with each release, they add one or more geoprocessing tools about machine learning algorithms. What do we mean by machine learning? I collected different definitions from popular books. The first, machine learning is the science and art of programming computers so they can learn from data. It is slightly more general definition. It's a little bit old. In 1959, machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. And this engineering point of view definition of machine learning, this definition from this popular book. The second definition is define the machine learning is as a subfield of computer science that is concerned with building algorithms which, to be useful, rely on a collection of examples of some phenomena. These examples can come from nature, be handcrafted by humans, or generated by another algorithm. Machine learning, I like this definition. Machine learning can also be defined as the process of solving practical problems by, one, gathering data sets, so we have data set, and two, algorithmically building a statistical based on that data set. That statistical model is assumed to be used somehow to solve the practical problem. I took this definition from this popular book. The third definition, the last definition of machine learning is one is one that is relatively difficult to summarize because it's often described or explained differently by different people or groups. As GIS, we have several and different definitions based on the people or groups. With that being said, the generally agreed upon definition of machine learning is machine learning focusing on the development of computer programs that can access data and use it to learn for themselves. Machine learning devices essentially take data, so we have data, and use to look for patterns and other pieces of specified information to create predictions or recommendations. So we have data to make predictions and patterns. This definition is in this book. Machine learning overview, this is very popular figure. Deep learning is a subfield of machine learning. Machine learning is the core or the first step in artificial intelligence. If we develop machine algorithms, it's difficult sometimes to say I developed artificial intelligence. We still have many further steps to develop artificial intelligence. There are several categories or classifications of machine learning methods, but one of the most popular classification or categorization of the machine learning methods is supervised learning. There are many algorithms under this part. Unsupervised learning, reinforcement learning, and semi-supervised learning. Also, there are many methods. So the comparison between the previous four methods regarding the input or and output in data mining, we know the input, but we don't know the output. So the algorithm in undermining will predict the output. In supervised learning, like classification or regression, we know the input and we know the output. In unsupervised learning, like clusters, we know the input, but we don't know the output. In reinforcement learning, we know the output, but we need some algorithm to predict the input. Machine learning algorithms, there are a huge number of algorithms. Small sample or small example is scikit-learn. Scikit-learn is the most popular Python package about machine learning. They classified the machine learning algorithms to regressions. There are many algorithms, and classifications. There are also many algorithms under classification. They have also clustering. They have many clustering algorithms, and finally dimensionality reduction algorithms. So they have four categories of algorithms. This is another example of machine learning algorithm, but not all of them. This is just few examples. For example, in clustering, there are almost around 100 algorithms. Also here for neural networks, there are many algorithms. In simple regression, there are also extreme gradient posting, one of the most recent regression method, XGBoost. So this is small examples of the machine learning and deep learning algorithms. So we have plenty and variety of algorithms. Can we say spatial machine learning or spatial deep learning? In Ecological Modeling Journal in 2019, there is a paper entitled Importance of Spatial Predictor Variable Selection Machine Learning. In the conclusion, the author said spatial machine learning applications and spatial machine learning applications. Also, Esri in user conference, in one of the technical sessions years ago, there was a technical session under the title GIS and Spatial Machine Learning. So the answer, yes, we can say spatial machine learning. Spatially explicit machine learning algorithm, Michael Goodchild suggested years ago 4 constraints about the spatially explicit algorithm. If the algorithm fulfill any one of these 4 constraints, so we can say this algorithm is spatially explicit. The presentation can be found on this link. Also, the advantages of spatially explicit machine learning method. In International Journal of Geographic Information Science, 2 years ago, they published a research paper, Geographical Artificial Intelligence, Spatially Explicit Artificial Intelligence Techniques. In the second section of this paper, they said recent researches have shown that spatially explicit models substantially perform more general models than when applied to spatial data. So if you have spatial data, try to focus first on spatially explicit machine learning algorithms. They are more preferred than general algorithms. These are some examples of machine learning algorithms in regressions, classification, clustering. Most of these algorithms are available in ArcGIS. I will show you later at the end of the presentation. So what are the checklists or the steps in this book? In one of the appendices, I think appendix B or C, at the end of this book, he suggested 7 steps. First, you formulate the problem and look at the big picture, get the data, explore the data to gain insight, prepare the data to better expose the underlying data patterns, explore many different models, and shortlist the best one that fit your need or fit your problem. Fine-tune your models and combine them into a great solution. Present your solution, launch, monitor, and maintain your system. There are some steps here. Sometimes we need to subdivide the data, training data set and test data set, and make some parameter, they call it hyperparameter tuning or something like that. Also, there are some general steps when applying machine learning algorithm, loading the data, and after that we clean. Sometimes we need to clean the data, dividing the data to training and testing data, pre-processing the data, creating the model, fitting the model, make the prediction, evaluate the model performance, and increasing the accuracy or the goodness of it, of this model by hyperparameter tuning. Some GIS software have a few number of algorithms. In this presentation, I will focus on 3 GIS software. Unfortunately, the unpopular software called Geodata software. It's a free GIS software with some machine learning algorithms like clustering and regression. There are some links. You can see some information about this software. This software developed in 2003 by Professor Luke and Celine in University of Illinois. This software works under different operating systems like Windows, Mac OS 6, and Linux. This software can integrate with R programming language and Python programming language by some packages or libraries. Since its initial release, more than 450,000 unique downloads. This is the one of the menu of the software. In the cluster, we can find some machine learning algorithm, for example, DB-scan, which is spatial clustering methods. It applied only on spatial data. Density-based mean DB scan mean density-based spatial clustering. Also under space menu, we find some algorithm or some statistical methods regarding spatial analysis, and also there is a regression. This is the GeoData software menu. In QGIS, most of the deep learning and machine learning algorithms are plugins or add-ons feature. So QGIS has more than 1,500 plugins. There are some or few machine learning algorithms or machine learning plugins or deep learning plugins. One of them called Smart Map for machine learning interpolation methods, Nmap Box 3 for image processing, cluster points for point clustering using several methods, MapFlow for feature extraction from satellite images using deep learning, automatic classifier for image classification using deep learning tools for training deep learning models, produce training data. This is the name of the plugins for deep learning for training data set. In Esri ArcGIS Pro, there are more machine learning and deep learning algorithms. They can be classified up to 4 subgroups. In classification, we have random forest, random trees, support vector machine. In clustering, we have density-based, space-time pattern. In deep learning, we need image analyst, which is separate extension developed by Esri, so we can generate training sample and detect the object or classify the pixels using deep learning algorithm. In the prediction, there are 2 main categories: interpolation or regression, like interpolation like empirical Bayesian kriging, and the regression is like a random forest or support vector machine. I will show you these tools in ArcGIS Pro later. Machine learning using programming languages inside GIS application. GIS application have limited number of machine learning algorithms, as we saw in the previous slides. Most of machine learning algorithms are available as libraries or packages in Python and R programming languages. R and Python are the most programming languages to deal with the machine learning algorithm, data analysis, data science. Most of the GIS applications have an integration with Python and R. You can develop your Python code inside the GIS application and apply machine learning algorithm on GIS layer and the spatial attribute table. In QGIS, for example, you can develop your R code directly inside the QGIS, while in ArcGIS, there is a bridge developed by Esri to integrate between ArcGIS Pro and R programming environment. Python and R are based on the library or packages. The most top popular machine learning libraries in Python and R are in Python, scikit-learn, which is the most popular machine learning package. TensorFlow, developed by Google. It's about deep learning. Theno, Keras, PyTorch, CNTK, NLTK, Open Computer Vision for image processing. In R, we have Carat, classification and regression techniques, Random Forest, which is a regression and classification, E1071, is a machine learning package, MLR3, machine learning 3, Kernel Lab, RBART, Sober, machine learning. These are machine learning algorithm which specialized in machine learning and deep learning, but we need some data manipulation package and data visualization packages. For example, in Python, we need NumPy and Pandas package to manipulate the data, and also we need SciPy and Matplotlib for data visualization. For R, we need dplyr and tidyr for data manipulation, we need ggplot to plotly and shiny for data visualization. These are some most popular books. Try to get the most recent one. This is the second edition. This is the second edition. This is the second edition. When you click in the image, I will provide you these slides because there are many links. If you click this on this image, you will go to the website of this book. There are also videos, slides, examples, exercises, codes of these examples. So there are plenty of resources regarding statistical learning. I will show you some. How many minutes do we have? I think still we have. I will show you. This is ArcGIS Pro. When we go to the Python, this is the environment. This is Python Package Manager, where you manage the environment of Python. These are the packages, Python packages for this. For example, let me show you SciPy, for example. SciPy, this is SciPy I mentioned before. There are many packages you can. The best practice is to clone, to make copy of this environment and add your Python packages. I will show you some processing tools classified under machine learning and deep learning algorithm. If you go to image analyst tools, you will find some tools. For example, here we have deep learning tools, but this is need separate extension or analyst or license. In space-time pattern mining, Esri recently added spatial time series forecasting, so you can evaluate the goodness of the fit of the four. There are 4 methods to evaluate between. Also, you have random forest machine learning algorithm. This is the most recently. I think they released this tools in January 2021. In spatial statistics, there are many spatial machine learning tools. For example, in this, we can, these are some tools in mapping clustering, for example. I will show you here density-based, which is a density-based spatial clustering. If you select the data points or polygon, and you select the methods, for example, let's see self-adjusting, you only need specify the minimum number of feature batch clusters. So we have only one input parameter. There is no need to specify the number of clusters. Most of the traditional clustering algorithms ask you for the number of clusters. If you select the dbScan, there are 3 methods, 3 algorithms. So you can specify the minimum number of feature per cluster and also the search distance. This is optional. And also this is optional. If you have a time field, you can run spatio-temporal density-based clustering, which this is a new feature. They added 3 months or 4 months ago. So this is spatial clustering methods. I will show you also some other examples. For example, this method, modeling spatial relationship, forest-based classification and regression. You can use random forest as classification and regression. This method can be considered as the longest or the huge tools in ArcGIS. First, to specify you want to train the model or predict. Let's say we want to train the model, then specify our feature layer, let's say the wells, and then we select the field or the attribute, or let's say TDS, and then specify the independent or dependent variable in in the table here, I will show you the attribute table. I will select from this attribute table, for example, I will select EC, I will select also basin, I will select BH, I will select independent variable as I can. Then this is categorical variable. Then I will, if I want the tool to compute the distance between the feature and linear feature. For example, these are the wells layer. I want to compute the distance between the well and the streams, or the building and the river, or the building and the streets. Or these tools provide you with spatial flavor, so we can specify the linear data. So this is streams, and also you can the tools can extract the pixel of the raster layer. For example, if I have the digital terrain model and I want to the tools extract the pixel value in these wells, so I will specify the digital terrain model, and also there are additional input and output. There are many other input. So I will not take huge time, but I want to show you some of the tools. So the importance of the independent variables. The AC is the most important, then the DTM, then the basins. Also the validation of R square. This is the validation R square, and then I will show you the output. This is the prediction. When you predict the model, you will get this non-linear relationship between the dependent and dependent. The machine learning and deep learning is a huge branch. If you are interested in new analytical tools, then I think machine learning and deep learning is the way to achieve this. This is what I have about machine learning and deep learning, and thank you for the listening.
Thank you, Dr. Fahd. Thank you for your wonderful presentation. And please, if you have any questions, please send it to chat box. Okay, Dr. Fahd, can you stop sharing your screen?
Yes. How can I stop sharing my screen?
Okay, I think.
Did I stop sharing my
No,
screen? Huh?
not
No?
yet. Not yet. Yes. I think you can find it on the top of the screen.
Yes.
Stop sharing.
Stop sharing.
Yeah.
Pause sharing, I think.
Stop sharing.
Stop. Yes, this is it. Yes.
Yeah, thank you.
No,
okay, now let's move to the second topic. Ethics of location data. Caroline, it's your time now. You can share your screen. Hello, Caroline.
Hi, everyone.
Hello, welcome.
Okay, can please let me know if you see my screen?
Yes, we can see it. Please start.
Okay, thank you very much for this opportunity to talk about this topic. So I'm going to be handling ethics of location data. So this session is going to cover about 4 things. Different aspects of location data, working with location data, a bit of ethical practices, and examples where location data has been used for good, and also examples where location data has been used and caused harm for different organizations. So we can start by looking at different definitions. Like for instance, what is location data? I'm pretty sure everyone or most people in this call are familiar and have worked with location data. So it's basically data that has identifying information on your location, in most cases, coordinates. And then we look at ethical practices. What is the definition of ethical practices, and what's everyone's understanding of ethical practices? So ethical practices is a branch of philosophy that deals with values pertaining human conduct. So to what degree is something bad and to what degree is something good, and what intentions are put into the different actions of, or rather the different outputs of certain actions, whether in a professional setting or in a non-professional setting. So ethical practices can be looked at in different dimensions. So they can be like systematic rules or guiding principles that guide people on how to act in different settings. So in our specific example, when we're looking at GPS data or location data, there are 4 specific ethical practices or ethical issues that we need to mostly focus on. That is privacy, accuracy, property, and accessibility. So when we talk about privacy, we're talking about how much information or how much personal identifying information is being collected about a user or an object in this case. Accuracy, so accuracy by definition of ethical issues is the reporting of the accuracy, the level of accuracy that your object or the tool that you're using to collect data is using. So for example, when you're reporting on accuracy and you're using a Garmin device that doesn't have very high accuracy, and then you report that you have collected accuracy up to about 1 centimeter, but in ideal sense, you have collected accuracy for up to about 10 centimeters, then you would not be practicing ethically in this example. So usually I like to give this example when I'm talking about accuracy. So in a situation where you want, someone has contracted you as a GIS practitioner and they want to look for the best locations to hide money, or the best location to dig up a hole and actually hide money. Sorry. I'm sorry about that, working from home. Yeah, so the example I was going to talk about when highlighting or when talking about accuracy is you have been contracted as a GIS practitioner, and this person wants to find the best location to dig up a hole and hide a significant amount of money. And in your contract, you have said that I'm going to provide the highest form, the best accuracy in a very specific location for you. But in ideal, you use a device that does not provide up to the millimeter form of accuracy, but or precision, but it provides, say, 10 centimeters. So this 10 centimeters in this example makes a significant difference. So the other issue, or the other issue to look at when you're looking at GPS data and ethical practices is properties. So what amount of attributes or for this feature? And then the other thing is accessibility of the data that you're collecting. So in the industry, there's aspects of open source and proprietary data that's been collected. So for instance, if an organization uses publicly funded money to collect data, then it's automatic that this information is needs to be and has to be made publicly available in different formats. But if an organization has used its own funding, even if the organization has used its own funding and or a person has used their own funding to collect this data, then they're not obliged to have this information publicly available. So in this case, the ethical issue is about communicating how accessible this data is going to be. Then the other thing I want us to look at is geoethics. So geoethics is around the same thing, like sort of the intersection of social and cultural implications of our practice or the practice of the industry. So where does technology and science start and stop when we're dealing with cultural and social practices in an area? So this mainly influences the awareness of societies or people regarding different problems of geoprivacy. And then this introduces a different concept called geoprivacy. Geoprivacy is a concept where we are looking at a lot of technologies automatically gaining access to your location information, and this location information picks identifying information about different users. So generally, geoprivacy can be defined as the individual's right to prevent the disclosure of your location. So different applications, when you download different applications from the iOS store or from Google Store, you're required or you're requested to say and to agree whether you'd like to share your location or not. A couple of years ago, this was not the trend. So it was more obvious, or it was more the to-go thing, where applications automatically gain access to your location. So now the concept of geoprivacy is where you actually get the right to prevent the disclosure of this information. So I'd like to also highlight a bit of a background to this topic as an upcoming or as an important trend in the GIS sector at the moment. So I'm sure we've all worked with location data and with different organizations using location data, and the use of location data has over the years become very, very important. Like traditionally, organizations that didn't require location data are actually now coming into adopting location data and geospatial analytics, eventually like gaining profitability or increasing the commercial aspect of their businesses. This has also opened up a lot of applications in different industries. Traditionally, industries where you'd think the application of location data is not as automatic. So I've seen examples of different advertising agencies in Kenya, for instance. And I'm giving this example in Kenya because I'm currently based in Kenya. So we see different advertising agencies where initially, about 5-10 years ago, the information about using geographic data was not very direct to them, but now they are among the top users of geospatial data and analytics. We also see a bit of commercial establishments, such as establishments that are distributing fuel within different countries, actually looking at geoanalytics and using location data, try to determine the location of the next petrol station or the cost of fuel in different locations and such things. So based on that, location data has revealed, it is known that location data reveals a lot of information about personal behavior, different patterns, and a bit of personal information. Yeah, so what are some of the guiding principles on use of data? So we've seen instances where location data is collected with your knowledge, in some instances where data is not collected with your knowledge. So as practitioner, and this slide is was put here, I mostly put this slide here so that you can speak to us as practitioners, responsibility of. So if I am responsible for collecting this data, what are some of the ways in which I can make people feel comfortable? And some of the ways include answering these very simple questions. And these simple questions increase transparency, and they make the use of the data that you're using ethical. So what is it that you're doing with the data that you're collecting? So for example, for software developers who are developing different applications for doing different things. For example, if you're developing a game and you'd like this game to collect data on where this person is playing the game, how old they are, how often they play the game, well, you have to put as part of your description, as part of the description of the game, that this is exactly why I am collecting this data. And how you're also going to collect this data is also very important, because if you're not explicitly telling your users how you're going to collect this data, then that becomes an ethical issue. Yeah. So I've tried to put down examples of ethical issues that are based on ethical issues that affect location-based systems. And one of the systems that I want to talk about is the RFID technology over the past very many years, and the privacy issues associated with RFID technology can be grouped into 4 categories. These are territorial privacy. So what is this about? So when you use RFIDs to monitor the location of an object, so that is by definition what territorial privacy means. So this means you're exposing the location of this feature or this object or this person, depending on what you're collecting. Then the other issue is bodily privacy. So this goes into the kind of attribute information that you're collecting. So there's RFID devices that collect or monitor the health of an individual. So in this case, I'm just using the health of an individual as an example. So what kind of information is being collected from this user? Is it the heart rate? Is it how healthy or how unhealthy they are? So this is very private information. So if the individual in this case that's being used as a case of where data is being collected is not familiar with or is not aware, it becomes a huge privacy issue. And then with communication privacy, so there's just before the introduction of emails and electronic submission of like information, there were instances where packages are being sent to different destinations, and then these packages automatically pick your location and they pick information about things around you. So that becomes like a communication privacy. So in this case, like when you receive unwanted information or unwanted information from a user who at the same time picks information about the IP address of your laptop. So they already have information that you did not give to them. That is what the issue here is. And then finally is the data privacy. So this speaks to even if a user had given permission or had let you collect the data that you're collecting, but you did not make it known what you're going to use the information that you're collecting for, then that becomes an issue. Remember, we've spoken about transparency, and one of the angles of transparency is explaining or making your user aware of the use of the data that you're going to collect from them. What is this data going to be used for? Is it going to be beneficial for them or not? And then they're able to give consent. So that is just a bit of examples or like an example of some ethical issues in data collection methods that we have used traditionally. But now, because of the way technology is changing, the way technological capabilities are changing, the way people's understanding of their rights is changing. So these are some of the issues that we need to be aware of. Like even if you're using a device like a GPS device, there's ground for explaining exactly what you're doing to the people that you're probably delivering the survey to, or you're using the questionnaires on. So there's been some methods or there's been some ways that scientists have come up with to use silently collected location information. And silently collected information in this case, for example, I'm saying, let's use the example of Uber. So if you have used Uber, they know your location, they know where you're coming from, they know where you're going, they have a bit of information about you. So, and I'm saying this is silently collected information because you don't allow them to collect a lot of information from the public. And these are some of the ways that some of this information is being used. So the first one is the stops, extractions, and homework leisure detection. So this is a methodology that's used to amplify GPS data or location data, where scientists are trying to identify interesting zones in a new location. So for example, if you move into a new city and you want to conduct a research on this new city without having to conduct surveys or deliver questionnaires. So this is some of the data that you can be able to use. So you can sort of identify interesting zones in these cities by using available available data like the Google API, the Uber H3 API that collects this sort of data. So I don't want to talk about how ethical or non-ethical this data is, or how ethical or non-ethical this method of application of this data is, but it's one of the ways that we can actually use to explore data that's publicly available. Then the other application area is the spatially augmented community detection. So this is mainly used in the urban planning field, where scientists want to understand the spatial distribution of different functions. So we want to look at if parks are located in this, if parks are located in this area of this country, how does this affect the movement of other city utilities? In other instances is where if public toilets are located near, say, a bus station in this city, how does this affect how congested this bus station gets at peak hours? Again, a very good example of data that has been collected silently being put to very good use. But there's also instances where the silently collected data gets into the wrong hands and it does more harm than good. Yeah. With this kind of technologies being available and these kinds of methods being available, there's also different techniques that have been created to work around, sort of create a workaround to this problem. So remember, when you're collecting this silent information, it is silent to us, but in the database where they've been collected, there's very identifying information about different users. So for instance, if they've collected data about 10 million people in Nairobi, then all these 10 million people are actual persons, person A, person B, person C, and there's identifying information about them. There's techniques that have been created to sort of work around this and still make this publicly available data as anonymized as possible. So some of these techniques include the spatial clocking. Spatial clocking is based on the K anonymity method, where we are trying to anonymize as much information as possible without losing the uniqueness of a data profile. What this means here is if we are collecting data on person A, person B, and person C, and we say we are anonymizing the name and age, then person A, person B, and person C have more similarities based on what we have anonymized. But what the K anonymity method does, and the best effort algorithm does, is to anonymize this data without uniformly anonymizing it. So we can say in person A, we are removing the age. In person B, we are removing the gender. In person C, we are removing the name. So this is one of the effective ways that I know are working in the industries. And it's like an area where a lot of data scientists are currently struggling with. So the challenge with this is that you sort of have to compromise on something. So it's either you remove privacy and maintain data accuracy and integrity, or you remove data accuracy. So this means you're sort of exchanging different aspects and attributes of this data with privacy. So it's like what do I call it? Like a catch-22. So you have to choose between privacy and data accuracy. Although this is one of the things that is currently has a lot of research going into. So yeah, so there's more research that's been focused on geomasking and also hiding the location. So this will automatically tackle privacy issues and still maintain our accuracy. So here I have some of the some examples of use of location data. I don't know if you know this. A while back, Strava was in trouble because of the use of the application by different soldiers who were in different military bases. And the challenge here was that usually when you use Strava and you're running in the morning, or you're walking in the morning, or you're exercising in the morning, and you want to share this with your team, or you want to share this with people who are around you, it automatically shares your location. So in this case, by the soldiers sharing their location and sharing their exercise activities, they unfortunately exposed their military bases, which led to trouble for the government. I've also seen instances where use of social media and location data has influenced political decisions or influenced the political geography of different countries. In this case, I'm going to use the example of Kenya, where a company will use the location information of the users of the platform, and then in additionally use the social capability of this social media platform to influence people. So other areas where location data has been used negatively has been where people use your data to steal your identity, and then your location data combined with your personal information, you're actually able to lose much more. And then in instances where people use your location data to track your behavior, track your habits, track your preferences and routines. So this happens a lot when you're using commercial applications on your device, or when developers create commercial applications that don't let the user explicitly allow for collection of certain information. So this is information that's being collected, for instance, when you're shopping on an application by a supermarket or a mall, and like say 10 of you are in the same location shopping different things, then this sort of creates a pattern for the mall. And this is information that when collected in multitudes, it's very, very helpful to this organization. It is commercially helpful to this organization, but then it raises the question of, are the users of this application aware of what this data is being used for? Yeah. So while I was preparing for this presentation, I came across different organizations trying to do different things. There are known guiding principles for usual data. There are known guiding principles where people in different organizations know this is the standard where you can use. This is the standard that you can use to work with data, but we don't have a standard of using location data. So this is what the Benchmark Initiative and the American Geospatial Society, the Ethical Geo Program, this is what they're trying to do by coming up with the locus charter. So this is a group of users with the interest to review the key areas where attention can be drawn to improve the standard of practice in using location data. So this leads to people protecting vulnerable groups. This leads to these efforts being able to safeguard individual privacy, as well as also safeguard the general public interest. So this is a group that's publicly available. It's a group where you can join and you can participate in. Yeah, so I've shared a link to that. I think they usually have meetups, but someone can correct me if they have more information on this. So these are some of the principles that the charter has come up with on working with location data. Yeah, we can talk more about this. So again, while I was still looking at this, I thought there's like the EU has the GDPR. Different countries have adopted or restructured the GDPR to work in their situations. I don't know if I can do this in this session or to wait for the Q&A session for us to have like some sort of discussion around the GDPR and how different countries are implementing this and adopting this to fit their situation, and whether it's working and what can be done about that. Yeah, so this is the last slide of my presentation. Yeah.
Thank you so much for that, Carol. I think you can go ahead with what you wanted to talk about, then Q&A can come afterwards.
Okay, thank you so much. So I'd wanted this slide to sort of be like a discussion of different people. It's amazing that this meeting is a meeting of people in different countries, so we can share experiences of the different adaptation of the GDPR in different countries. Yeah. Does anyone have examples where this has been adopted and it's working for them, or where they have actually created data practicing principles and standard and they are working for them? Okay, So if no one has anything to share, I can talk about the case of Kenya. So Kenya has a data protection bill that actually looks at what different organizations do with the data that they're collecting and how they are collecting this data. So this is a very good bill because it protects users who are not aware that their data is being collected and how it's being collected, and the organization that's actually collecting this data. So I'd say in this case, in the case of Kenya, we are not yet there, but we are headed there. It doesn't speak much on location data, but it generally talks about collection of non-spatial data. Yeah, in this case. Okay. I'm sorry, I don't remember who the moderator is, but I would be open to taking questions now.
Okay.
All right, thank you, Carol. I think there are a few questions in the chat box, and I'll just be reading them out to you. Questions directed at you. There's this one. There's a question about geoethics, data ethics, etc. Aren't all these ethical issues? Do you fall under the heading of work ethics as a whole? That question comes from Nasa Sadi.
Okay, so I can start with that. Okay.
Yeah.
Okay, thank you so much. So ethical issues can be looked at in different ways. So we have ethical issues in technology, we have ethical issues in the study of different things. So specifically when we're looking at geoethics and data ethics, we can look at this separately. So like geoethics, for instance, this is like the practice of us being able to understand where technology and science starts and ends, or where technology and science actually meets the social and cultural practices of people within a region. So a good example of this would be where you're going for a data collection exercise and you're using devices that people are not familiar with. So this can sort of hinder the amount of information that you're going to collect. So in this case, the standard would be you're presenting your data collection efforts in a way that the community is accepting of it. So you're not, let me just use annoying. You're not annoying anyone in your want to collect data. Yeah. And data ethics on the other hand is the application of your data. Remember the 3 questions that probably everyone who works with data should be asking themselves. Why are we collecting this data, or why do we have this data? How are we collecting this data? And where are we going to use this data? So like these are things you as a user, as a manipulator, as a giver of this data, like these are some of the key things that you need to ask yourself. And these broadly describe data ethics, because again, they also talk about the issues of transparency. They talk about the issue of accessibility. Like in a case where I have downloaded an application from the Google App Store, and this application requires me to send them details about my gender. So does this mean that we are doing a data exchange? So when I share this information about myself, and then 5 million people also share this information about themselves, do all these different users have access to this information? So this is so these are some of the guiding principles that the application needs to make people aware. So if you share this data, you either have access to the data to the collective data that we have collected, or if you share this data, you don't have access to the data that's been collected. So ethics is generally about communicating and being transparent in the aim of the aim of this data collection exercise. The second part of the question was, aren't all these ethical issues that fall under the heading of work ethics? Yes. The broad answer is yes, because work ethics then covers transparency and communication. So if you look at all these ethics issues as one, then I can broadly say that they would fall under work ethics.
All right, thanks for that, Carol. Assuming you've answered that question. Another question to you goes, somebody is asking, when we visit a place, Google tends to ask, how was place XYZ? Is that ethically right? The person also says, in my country, I don't think there's something like that.
Okay.
That question is for you, Carol. Yes.
Yeah, thank you. Thanks for the question, Sharon. I've also really battled with the question of, is the data that Google collects ethically collected, or is it data that we are just giving them because we don't have an option but to use the application? I think before you set up your Google account, there's a lot of what do I call them? Terms and conditions that you need to read through and agree or disagree. So this is part of that, especially when you're using Google Maps. Like the very first time you set it up, I'm sure it had asked whether you'd be okay collecting this information. Are you okay submitting this information about places around you? And then we say yes to that. So ethically, Google is not ethically wrong to be using your location information to ask you about an establishment that you're visiting, because you agreed to contribute to the platform when you started using the application. Yeah.
All right, thank you, Carol. Few questions. So I don't know if you'll be open to answering them now. Dr. Fahad, can we get an affirmative answer to that? Is Dr. Fahad still on this? We have quite a few questions for him. Okay, so while we wait for him, or I'll just read out some of his responses to previous questions. So the question went to Dr. Fahad, is there any resources or books that basically talk about machine learning and GIS? And will you recommend any? I think he responded by saying he didn't see any book about machine learning and GIS, but there are a few books about special data sciences, and he dropped a link to that. He said also promised to send his presentation. So I guess we'll be sharing that afterwards, probably in the emails. Also, there's a question here about if anybody is interested in applying ArcGIS machine learning tools. Okay, Dr. Fahad responded that he published some articles. He sent the link also. So please check the chat out for some of Dr. Fahad's articles about machine learning and GIS. So thank you very much, Caroline. I think in the absence of any more questions, we could just round up the session by saying that if anybody is interested in joining the Women in Geospatial, as well as the African Women in GIS network, the links are in the chat. So I'll just reiterate again that in case you probably stumbled upon the webinar, the Women in Geospatial Plus network is a global network of women and females and underrepresented gender groups in the geospatial industry. And it's free to join. Anybody can join as long as you're a woman or underrepresented group. The links are there in the chat for Women in Geospatial as well as the African Women in GIS. The African Women in GIS is an African-centered group about women, for women in the geospatial industry in Africa and for Africans. It's also free to join. The network is free to join, and the links are also in the chat. So without further ado, I would like to say a big thank you to everybody that has joined us so far in the webinar series. My name is Opayemi, and I belong to the Women in Geospatial as well as African Women in GIS networks. And we are saying, on behalf of the network, we're saying a big welcome to anybody that is willing to join us. Please signify if you don't see the link. I'll try to send it once again so that everybody can get the link to register in case you haven't already. And if there are other questions or concerns or anything that you want to know afterwards, you could send emails through the network, the email address that sent this link to you. So we thank you very much for all the participants as well as the guests that we've had from day one. Say a big thank you to everybody for making this a success, and in the access, okay, thank you very much. I see the vote of thanks in the chat box. In the absence of further questions, I would like to end the session and the webinar series now. Okay, once more, the link has been shared. The link to the to join the Women in Geospatial groups, as well as the African Women in GIS. The links have been shared once more. So I'm trying to wait a bit for us to get the links if we've not already. Yes, the link for Women in Geospatial Plus has also dropped. So we'll try to hold on a bit for everybody to get the links and join if they want to. And all right. So with that, we'll say a big thank you and bye-bye for now.